Hello everyone, welcome to the next lecture in the course. Today we are going to start a new topic where we are going to discuss about the various platforms that we use for remote sensing observations. Remote sensing basically needs some sensor to collect the energy from our target. So, in order to carry those sensors we need certain platforms, and the characteristics of those platforms will affect the way we do remote sensing. So, that is what we are going to discuss in starting from today and in the next few lectures. There are plenty of platforms available for performing remote sensing, and in the earliest lectures I told you there is like no defined distance between the target and the sensor at which we call the observation as remote. Like we can even like do some sort of like measurement standing on the ground, but even if we still do it without in contact with the land surface or whatever the target we need, we can call it as remote sensing, technically speaking. So, the platforms which we do to collect data or the platforms which we use to collect data can be classified into several kinds, like ground based or in situ platforms, aerial platforms or low altitude, which is just fly in a short distance up in the sky, or space borne platforms. Like a few examples given in this particular slide. Here you can see like ranging, there is like a very large range in the distance from the target. Say if this is like the target, the sensor can be placed anywhere in the distance ranging from 1 meter to, say it depends on the height at which we place the platform. So, these are all basically the towers and handheld sensors are basically in situ platforms or ground based platforms. Then we can have these categories, UAVs, stellar balloons, so they are like low flying platforms. They are like airborne, but still they fly pretty close to the ground. Then we have this aircraft which can fly at a slightly higher altitude in the range of few kilometers. Then we have satellite in the between the altitude range of 200 kilometers up to, say now even we have like most often we use 36,000 kilometer as earth observation target, but we can place satellites at a very far distance also, like low earth orbit satellites and then geostationary satellites. Low orbit satellite typically in the range of 200 kilometers to 2000 kilometers we can say. And then we have this geostationary satellites orbiting around 36,000 kilometers away from the earth. So, this slide basically tells us the distance from the target at which we collect the data can vary very widely, and each of its platform has its own application in remote sensing. So, that is what we are going to discuss. So, the first category of platform that we are going to discuss is the ground based platform or in situ observations. Ground based platforms in general means whatever sensor we carry, we keep it close to the ground. For example, here in this particular slide we have like a person collecting data above the field, like this is like a handheld instrument what the scientist is using there. So, this handheld instrument is called like spectroradiometer, which is useful to collect spectral reflectance curve of the land surface objects. So, this is basically the sensor, it has like a computer, it has like a computer here, it has like a backpack here which contains the actual control unit and everything. So, this is kind of like it will observe earth or whatever the target source within like a small solid angle, similar to how like a satellite based sensor observes, and this we can use it as some kind of like reference for our various applications. So, this is an example for an handheld sensor. So, the sensor is held in human hand. Similarly, we can mount some sensors in trucks. Say these are like some example, they are like plenty of sensors fixed within those boxes. They are mounted to trucks and they are used to collect data. They also like certain like a small solid angle on the earth surface collect the reflected energy or the emitted energy from the earth surface. Similarly, we can place such sensors mounted on towers. It is also possible. Say we can keep, let us say we have a tower like structure here, we can keep the sensor mounted on this tower. It can be a kind of like a semi permanent installation, it can be there for few months or few years, or it can be there permanently. So, in situ sensors actually can vary or it can come in different form, not in situ sensors, the platforms. It can be carried, human itself is a platform. If like in the scientist given in this particular slide carries a sensor in her own hand. So, it is like a the human being herself, like she is acting as kind of like a platform. Similarly, we can like use trucks as platforms, we can use towers as platform and so on. See, again another example is given in this particular slide. So, here we have like two persons who they develop something kind of like a movable truck kind of thing, which is like it can move basically, which has like a array of sensors. You can see here it has a thermal infrared radiometers, it has a spectrometer, NDVI sensor, web camera, GPS receiver, weather monitoring sensors and all those things. So, they use this for kind of like an integrated agricultural applications. So, these are all like different ways in which we can collect data standing on the ground itself. This is also like example for remote sensing, like technically speaking, like we are not in contact with the earth surface from which we are collecting the data. We are having the sensor at certain distance, and still the working principle of those sensors, like the say here we are showing a thermal infrared radiometer. This sensor still works in a remote way, like it just observes the emission from the ground surface remotely, whatever is coming within the solid angle, and we can use it to estimate the land surface temperature. So, all these kind of platforms which we use for collecting data standing on the ground, we call it as ground based platforms. Okay, why do we need a ground based platform in the first place? So, the ground based platform is essentially necessary for several things. One is calibration and validation of data from other sources, like when I discussed about radiometric properties of optical sensors, I told like we need to do what is known as like radiometric calibration, that is relationship between the DN recorded in the sensor with the actual radiance that is coming in from the ground, right. So, for those sort of calibration exercises we need reference data which has to be collected from the ground, because when we collect data standing close to the ground, we are effectively removing the effect of atmosphere, right. So, that is one way, like if the effect of atmosphere will still be there at least for the few meters, but it will be much less when we compare it with the orbital height of a satellite. Similarly, for validation purposes, say some variable we might have calculated from satellite based data, we may need to validate it. For such activities, ground based observations are mandatory. Like for almost all satellite missions, people will do a calibration and validation exercises where they will collect ground data at the same time of like satellite overpass or aerial flying whatever, so that the ground based observation can always be checked against or it can be used for validating the satellite based or aircraft based observations. That is one thing. Ground based observations can also be used for proof of concept testing of new sensors, like whenever a new kind of sensor for remote sensing is proposed, it will not be directly put into a satellite and sent to orbit. First, such sensors will be tested using such ground based platforms such as like a truck mounted. Say for example, here you can see in this particular slide, we have this particular mount inside the truck has several sensors. It has like an S band radiometer, like a passive microwave radiometer, L band passive microwave radiometer, a hyperspectral spectroradiometer, a thermal infrared probe, a C band radiometer and so on. So, basically if some new kind of like sensor, if it has to be tested from first, they will test it using such sort of like ground measurements, then it will move to aerial platform, then only it will be sent to space in a satellite. So, for testing some sensors, ground based platforms will be useful. If someone designs, okay, this is like a new way of data collection, it will give us like a complementary data for what we are doing, means first people will mount it on such in situ platforms, either on a tower or on a truck. They will collect data from the ground, they will try to analyze it in conjunction with other variables, say crop variables or land surface variables, then they will understand, okay, this data or this new sensor is pretty much useful in a particular manner. So, for that sort of proof of concept testing, in situ observations will be useful. And then remote sensing data analysis, like in the previous slide I showed you like a scientist collecting data using a handheld spectroradiometer. So, that is kind of that particular sensor will give us a spectral reflectance curve. So, that spectral reflectance curve we can use it as a reference and we can match our satellite observed spectral reflectance curve and say okay, this particular pixel in a satellite gives a spectral reflectance curve similar to vegetation. So, the pixel there may contain vegetation. For this sort of like image analysis to understand what is contained in an image, the reference data can be useful, and for collecting such reference data ground based platforms can be used. So, as I said before, the ground based platforms can be collected in many different ways. But ground based platforms comes with its own limitations. They are like it needs extreme or careful planning, like what to collect, when to collect, how to collect, like I am talking about data, what data to collect, in which mode we have to collect, all this kind of planning should go on. It is laborious, we need people physically visiting the field to collect the data. It is cost intensive, like it needs lot of money to conduct like ground campaigns. It is not like an easy task to conduct ground based campaigns, it involves lot of money actually. So, it is expensive, it is laborious, lot of people should spend enormous amount of time in the field, preparing the ground based sensors, going to field, travel involved, data collection, all those after like post data collection, its processing, all those things takes enormous amount of time. Actually, in order to overcome the disadvantages of the in situ observations, remote sensing has gained so much attention. Like we cannot do in situ observations all across the globe, it is next to impossible, I will say, if not like perfectly impossible, because we observe like hundreds if not thousands of variables related to this earth system, and if you want to monitor everything sitting from the ground, it is going to be extremely difficult if not impossible. We cannot conduct ground based campaigns for everything, but without ground based observations also remote sensing from space does not exist. Like does not exist means it will not be of much use. We need always some sort of ground based data collection to advance or to support remote sensing activities from space. So, in situ observations are indeed needed. Without that, remote sensing is not going to be as effective. Here remote sensing, I mean remote sensing from space, it is not going to be as effective, but at the same time in situ observations alone cannot help us to collect various data we need over different places across the globe. Okay, now we move on to discussing about the low altitude aerial platforms. So, what are low altitude aerial platforms? They are those platforms which will carry the sensor to like a small amount of height, say hundreds of meters or less than a kilometer basically from the earth surface, or at most can be tens of kilometers at most, I will say. So, these kind of aerial platforms, in the olden days people were using balloons like hot air balloons or motorized balloons called blimps, or even like in very olden days people were using like even very large kites to carry like photo cameras. They will like fly it in space and observe various parts on earth, or even pigeons, like as given in this particular slide here you can see like a pigeon attached with some sort of like camera fitted to its body. Since pigeon has like a very good directional capacity, we can ask it to go to one particular place and come back. It can go, if the photograph can be taken automatically by the camera, then the pigeon has to just fly and come back. So, we can like take the photographs and use it for reconnaissance purposes. So, mostly this kind of aerial platforms developed in olden days mainly for military applications basically. Especially they grew or they got so much attention during like World War, even before the invent of aircraft like World War I, where the aircraft technology was still at its nascent stage. They were useful. Even before World War, people were using this sort of like reconnaissance mechanisms. So, they were like used in much olden days. Now, in recent decades like last 1 decade or so, unmanned aerial vehicles has gained tremendous attention, and that particular field has grown leaps and bounds. So, UAVs, or in short, can come in many different forms. A few examples are given in this particular slide. You can see like UAVs comes in different forms, they comes with different capabilities and so on. So these sort of UAVs can fly even very close to the earth's surface or in altitude of like few tens of kilometers. Like some military grade autonomous UAVs can fly at a very high altitude for reconnaissance purposes. So these UAVs can carry multiple sensors, they can fly whenever we want, etc. So this kind of UAVs have also gained lot of attention, and in recent decades people are using it for anything, like we might have even seen it in our friends or relatives wedding, like even it is used for like starting from simple event photography to various remote sensing applications. We can use UAV, and UAVs are kind of one of the most widely used low altitude aerial platforms. So again, like another example for a UAV sensor is given. Then comes aircraft. So aircraft essentially is I would classify it as like a aerial platform which is capable of flying at certain amount of height, like easily it can fly above UAVs or whatever, like pigeons, kites, balloons, etc. Aircrafts actually were like after the development of this aircraft technology, immediately it came to use for remote sensing observations, especially in the especially for military needs. During World War II and all, like aircrafts are used extremely for military reconnaissance applications. So even from that day and even now, aircraft plays a major role. Like just before a few slides I told you that whenever like a new sensor is going to be developed, people will always conduct like a ground based platforms, where during ground based platforms definitely aerial campaigns also will be there. Aerial campaigns means like a prototype of a sensor which has to be sent to space will be mounted in an aircraft. It will be flown at different places across the globe, and then people will all at the same time will collect ground based data. So the sensor characteristics will be studied in detail from the aircraft first before it is moved to like a satellite. That is one thing. So aircraft is again like widely used even for even before like a sensor is launched. We now just got briefly introduced to different kind of low altitude platforms, starting from kites, pigeons, balloons, UAVs and aircrafts. So now it is time for the students to think. Please pause the video for a second and then compare these different low aerial platforms and analyze it in terms of cost, spatial coverage, what are its advantages, platform stability, accuracy of output products, anything. So please pause this, think in detail about such aerial platforms, and then you can rewatch the video for further discussions. Okay, now hope you all like had a chance to think about these platforms. We will discuss these platforms and compare them with each other. First of all, what are the advantages of these aerial platforms? The major advantage of aerial platforms is we will be able to collect data whenever we need. That is like a major thing. Say for example, for satellite means we will not be sure whether the spaceborne satellite will be collecting data at a place at a given time. Satellites are defined by its own orbit, which we will see later. We have to wait till a satellite comes to our place. Similarly, ground based platforms also means it may take us some time. We have to plan, go to field. Say if you want to collect data over like a big district, then ground data collection may take weeks together. But aerial platforms, they are relatively faster than ground based platforms. So data collection can happen quickly in compared to in situ observations. We can collect data whenever we need. Like if I say okay, there is like a flood in a given state, I can use airborne sensors to collect data over the field even if satellite is not there. If something happens during like night time when satellites are not overhead, immediately I can fly an aircraft if it is available with government agencies. So all these, if this anytime operation is like the major advantage of aerial platforms. But if we compare the different kinds of aerial platforms, what we can understand? The first thing is we will discuss in terms of like cost. Like the kites, balloons, pigeons, they are like very rudimentary, like olden days people are, in fact balloons are still being used, but still they are like somewhat like relatively older technology. Cost wise they are less expensive. Like here I am talking only about aerial platforms, okay. So kites, pigeons, balloons, UAVs and aircraft, 3 different aerial platforms I am discussing. So the kites, balloons, they are like relatively low cost. If you have like a sensor, that will be like the major cost, the major cost will be towards the sensor, other things will be cheap. Also like then if you come to UAV, slightly expensive. Say if you talk in Indian context, the UAV will be costing in terms of few lakhs, even like a basic model. Even when you use UAVs that are being used for like photography in weddings, they even cost like few lakh of rupees. And if you want like a real good survey grade UAVs, they cost few tens of lakhs, and really advanced UAVs they may even cost in crores of rupees. So UAVs are expensive. Similarly the sensors that comes with UAV, they are again expensive, and also like nowadays most of the UAVs comes bundled with its sensor, like there are like different manufacturers for UAVs, they also develop their own sensors, and normally a sensor from one manufacturer may not sit in the UAV for sensor from another manufacturer. So that sort of interoperability is still not there. We have to, if we purchase like if we purchase a particular UAV, a particular brand, we may have to go to the sensors from that particular brand actually. The interoperability of sensors is still not there. So it is kind of like expensive. Aircraft further expensive, like maintaining an aircraft we may not do, we may have to hire an aircraft, the rent itself may be extremely costly, and also we need extreme amount of training. Like even for UAV you need like a minimal training, but for like piloting an aircraft, operating a sensor, sitting within an aircraft, they have lot of technical complexities. So each one is like will be going increased complexity, starting from this balloons to UAVs to aircraft, cost will increase in that order. Similarly complexity also will increase in that particular order. Then we will talk about the spatial coverage of this. So normally the balloons, kites etc., they are used to collect data over like a small region, maybe like a single village or so. Those platforms we cannot rely to collect data over like a large region. Even like 2-3 streets they may cover, that is it, very small amount of area. UAVs we can use maybe like a square area in terms of like square kilometers, we can use them. Some UAVs are capable of flying even for tens of kilometers, but whatever we have access to, like normally what we use for our typical day to day applications for remote sensing activities, they can fly for certain distances, and maybe like a few square kilometers of area we can cover in one shot. Aircraft, they have like a really good spatial coverage, they can fly hundreds even thousands of kilometers if properly planned, they can cover like a very large region in a short amount of time. So that is like the spatial coverage, and also time wise aircraft can give you really quick coverage over like a large area. Only thing is aircraft needs like a perfect landing and takeoff facility, whereas UAVs they may not need it. Some UAVs can take off and land from anywhere. Only even if they need landing, it may not require as huge runway typically required by an aircraft. Okay. So spatial coverage is good in aircraft, like extremely good in aircraft, good in UAVs, and pretty much low in balloons or kites or some kind of thing. And anytime operation, any of this aerial platform can be carried out for anytime operation. Then comes the important thing, the platform stability. So normally balloons or UAVs, they are highly affected by wind or other disturbing factors that may change the platform stability and change its attitude. Say you are like flying a balloon with some sensors attached to it. If a sudden gust of wind blows, the balloon may deviate from its path. Same thing may happen with the UAV also. If a UAV is flying, suddenly its attitude may change, it may give like a small roll, it may pitch, it may whatever can happen, affecting the platform stability. Once the platform stability is affected, then the image we collected may not be as good enough. It may not satisfy the specifications that we need, that is one thing. But aircraft provides like a really stable platform. Among these things, aircraft is like the best platform to achieve like stability, because it can fly well over any sort of disturbances like wind gust and everything. So, typically it will be more stable when you compare with other things. Ultimately the platform stability will affect the accuracy of the output products. Say normally nowadays when we do air based or airborne data collection, definitely we need the coordinates of the aircraft or the platform to be collected every day. Like normally people who are used to UAV technologies will know this. Almost all the survey grade UAVs comes with a GPS receiver. It will be collecting data from GPS satellites continuously. That is to improve the accuracy. Unless we know the position of the aircraft, it will be impossible for us to georeference the image. Same thing applies with aircraft and also to satellites. We need to know its position perfectly. So, that one, like the position of the aircraft plus the attitude of the aircraft, like whether it is like perfectly straight or if it is like tilted some direction, we call it as attitude. So, that attitude of the platform plus its position will ultimately determine the final accuracy of our remote sensing product, the geometric accuracy I am talking about. Say if you are collecting data over like a particular region, your image should perfectly tell, the coordinate should perfectly point it to that region. Okay, so that is what we call it as like geometric accuracy. The image should not be distorted. If there is a circular feature on the ground, it should appear like a circle in the image. All these things relate to geometric accuracy concepts. So, aircraft gives you like the highest, you can achieve like very high geometric accuracy. Even from UAVs, if the operations are performed in an extremely careful and planned manner with lot of ground based GPS stations, we can achieve very good accuracy. But balloons, such things, we will always have to sacrifice accuracy to certain extent. And all these things whatever we have discussed are essentially the comparison or like a brief discussion about the different platforms that we use for different aerial platforms that we use for remote sensing observations. So, as a summary, in this class we just got introduced to what a platform is. Like a platform is like a tool or a medium to carry a remote sensing sensor, and platforms can be of many types: ground based, air based and space based. So, in this class we got introduced to ground based platforms and aerial platforms, and we discussed different classes of aerial platforms. With this we end this particular lecture. Thank you very much.